In the previous lecture, we discussed the testing hypothesis about the two population means in case of independent sample. Today, we are going to discuss paired sample cases. What does it mean, paired sample? Let's discuss about that. Suppose there is a typing education to increase the speed of typing. Suppose you want to collect a sample from, before, after the typing education separately, what would happen? Well, typing speed is much depend on the personnel. Okay? Somebody is doing typing very well, some are not. Therefore, individual some difference cause lots of problem. Maybe you cannot test whether typing speed increases speed or not. How can you do that? Here's a simple idea. Suppose you collect a sample at the beginning, before the typing speed, and before typing education. Suppose you are going to check the same typing speed using the same sample. We call that is paired sample. Yeah? Simply we are using same sample you selected before typing training. Well, if you have this kind of data set, we call this is paired data. Any other example you can think? But there are many examples in case of medicine or some clinical trial. It much depend on the personal things. Okay? In that case, we are using the same sample before, after taking some kind of drug. Okay? We call that is a paired sample. Suppose you have a paired sample, therefore you are supposed to have a same number of sample. Then you collect just the difference. Okay? If this kind of difference near close to zero, that means there is no difference. Okay? We want to check that. How can you do that? On this difference data, you calculate average of them. We call this is d bar, and average of this, the variance of this di, we call sd square. If mean is close to zero, we'll assume, well, there is no difference. If it is some kind of positive number, then the population 1, the people you do something, is greater. Less than, well, we consider population 2 is greater, like that. Well, as far as this single data set concerned, we already studied that. It's a testing hypothesis about the population mean. It is the same thing. Well, therefore, this decision rule, even if you have two population before, after, like that, the test statistic is using sample mean of deviation and sample standard deviation. It is the same thing as a single testing hypothesis about the population mean. These are the test statistics. And it follows Tn-1 degree of freedom. Depending on alternative hypothesis, we have to consider right tail, left tail, or two-tail cases. Let's consider this example. Well, this is the type of training example. Before you have some training, after training, we select sample 8 using the same sample, that is paired sample. You test typing speed after training. We have to test that. What is the null and alternative hypothesis? In general, you may say mu1 minus mu2 equal d0, but in this case, D0 is a gap. If you consider this is 0, you may say mu1 equal mu2, or this is mu1 less than mu2. If it is 0, that means after training, the typing speed increased. Okay? We have to test this alternative hypothesis. Decision rule is you calculate differences like this and test that whether these differences are equal 0 or not. Therefore, you calculate d bar, mean of these differences, standard deviation of this one, and apply test statistic. It shows negative 3.13, and therefore, if it is a negative number, what does that mean? If it is negative number, well, there might be chance H1 can be accepted, but let's test that. The test statistic is minus 3.13, and T(n-1) alpha using significance level 5%, it is negative 1.895. Therefore, it is more beyond of this critical value. Therefore, H0 is rejected. That means training increased the typing speed. How can you practice? In case of E-stat U, it is so simple. You just type these numbers before training. This is after training, and you select some paired sample. Okay? Therefore, you are supposed to have the same number of data. The clicking execute button will calculate the mean of differences and variance of differences. And then the test result will look like this. It is reject H0. Well, in case of E-stat, you can do the same thing. Let's practice that. Are you ready to use E-stat? Click EX button and click eBook. We are in chapter 8, EX0801. It's a typing speed problem. Can you see that? If you have this kind of data, you can click the testing hypothesis about the mu1, mu2, and click these two variables. Okay? Then they show the dot graph of distance data, difference data. Then you just click just t-test if it is 5%. Well, if you click this one, they show some result like this. Okay, it should be rejected. Here's the output for that. Well, this is paired comparison cases. Here's a test statistic and p-value. It shows you have to reject H0, okay? Because p-value is very small. Okay, this is testing hypothesis in case of paired data. Okay? Be sure what does it mean paired data. If there is individual difference, you have to apply this technique to compare to population means. See you on next class.